For this project, I created an algorithm that turns my laptop into a smart doorbell that monitors when somebody leaves or enters the apartment. This algorithm basically works by having a continuous loop of taking two images back to back with 2 seconds in between. It will then use these two images and apply a mask to it to basically crop the image to an area of interest. And then this area of interest itself will be resized to a smaller image size. And that smaller image size will be grayscaled and also blurred. And then from this final edited photo, you could then compare the two images' data. And if the differences in the images are significant enough, it'll then create an alert that somebody's at the door. So this alert, it prints someone's at the door, and then it'll create a video that's 5 seconds long of somebody entering or leaving the apartment. And it will save that video to the laptop. And then also with this alert, it'll create an email saying someone's at the front door, and it sends it to my email with a camera alert as the title, and it'll have the two images attached that had the data that was compared just to see that somebody was at the door. Now let's see this algorithm in action. Right now it's taking a second to initialize the video camera. Now it's taking the two images. As you can see, I'm not currently in frame, but here are the original images that are masked, and then those images resized, grayed out, and blurred. So it's just continuing to go through the loop. Let's see what happens when I get closer to the door. Okay, so as you can see, the camera was on for 5 seconds, which meant that it was recording the video. Let's see what the comparison photos look like. There it is. As you can see here, this is the video that I just captured. I'm standing there, I was at the door, and then I came back. And then it created an alert, this news email. Here's the two images that I compared to say that there was someone at the door. When creating this algorithm, I basically followed the general detection pipeline that we used when we were building this code in class. So I didn't really add any extra steps. Something that I did do was that I had to create a custom mask for my area of interest, which is different than the one that we created in class. And I also did change some values, such as increasing the threshold for the difference between the two images. The original value that we used in class was 15,000, and when I was testing it out in my apartment, I found that like moving around created shadows on the door that wasn't necessarily somebody at the door. It just changed the like final grayscale blurred value that you'd find at those pixels. So I decided that I had to increase the threshold so it wasn't detecting a shadow as a person. I increased the threshold from 15,000 to 90,000, and I found that that worked out pretty good. Also, something that I did change, I don't know if this counts as changing in the detection pipeline, was that in the original code, it had it so that you were initializing the camera for creating the video within the if statement after the difference being above the threshold. And I found that this made it so that it took like 2 seconds to actually initialize the camera, and by that time, the person could have possibly gone through the door and out of frame. So I decided to actually initialize the camera at the very beginning of the code, and then in the if statement, I would close the camera and then reopen it for the next loop. I know I already talked about my changes with the detection threshold values, but I want to also talk about the kernel size and the time delay between images. So for the kernel size, I didn't actually really change it from what we had in class. I found that like what I had from just the detection values was actually good enough for detecting if someone was at the doorway or not. And then for the time delay, I did mess with that. The final value that I used it did end up being the one that we had in class, but I chose that because when I decided to make it less, I realized that it was making the difference values between the images smaller, which was already something that was rough when comparing it to shadows on the door. So I decided to go with 2 seconds, which was like a good enough time between images to see if someone was at the door, because it could take like 2 seconds to unlock a door and open it. And then for talking about things that could possibly improve the algorithm, since recognizing if someone or something is in a defined area is basically just done by comparing 2 images, it could possibly be better to use different values to compare the images. We use grayscale in this, but it might be better. Also, we did a difference in grayscale values for the whole image. It might be better to do like pixel by pixel, see if it changes within a certain range, and then how many of the pixels change within that certain range of values. Then if that is above some threshold, that might mean that something significant is in the user-defined space. Or you could also maybe use a different color scale. You could use RGB or HSV. It might be better than using grayscale, even though grayscale does simplify it. So putting those 2 ideas together, it might be better to do an RGB or HSV scaling, doing pixel by pixel within a certain range and counting those, rather than taking a image-wide grayscale comparison between images. This is because it's possible for 2 RGB colors, like the background and an object moving through it, to have the same grayscale value, so it would just blend in. And also because with the grayscale, the shadows actually do affect it, and that can be mitigated by using a different color scale.